Hey guys, and welcome back to Geometry. Today's video is going to be on transformations, specifically translations. If you need to hit pause on this video to start writing down what's shown on the screen, feel free to do that because we're going to jump right in. Okay, we're going to get started with the news you can use, which is basically just defining some key vocab that we'll be using throughout the video. So the first vocab word is the word point, okay? So it's important to note that a point has no size, no dimension, but it does define a location, kind of like a map. Okay, the next word that we're going to define is actually the word translation. So translation is a transformation that slides. Whoops. That slides an object left, right, up, or down. Okay. And it's important to note that in translations, congruency is preserved. Congruency is preserved. So congruency is another word that we're probably going to need to define. So let's go ahead and define that right now because we're going to be using that a lot in geometry. So congruent means that something is the same size and the same shape. Think of it as like the geometric word for equal. Okay, so when we say that translations preserve congruency, that means when I'm moving a point left, right, or up or down, it's going to stay the same size and the same shape. Okay, so now let's talk about translation notation. So when we're talking about translations, there's a special way that we notate this. Okay, so go ahead again, hit pause, and copy down what's on the screen. Welcome back. Okay, so here's how we use translation notation. So if I'm trying to move a point up, I'm going to take the original point that I was given, which is x comma y. And if I'm moving something up, that means I'm moving along the y-axis. So I'm going to change the y. So if I'm going up, I'm going to do y plus some number. Okay, this right here, this just means that it's talking about the original point. Okay, and if I'm moving up, that means I'm going to do y plus some number. Okay, so now if I'm moving down, what do you think that's going to mean? If you say that your y, it's going to be y minus a number, then you're absolutely right. So y minus a number. So again, this xy, that first thing you see there, that's just referencing the original point. So it's saying, hey, take this original point and shift it down. So if I'm talking about moving a point down, I'm talking about y minus something. Okay, so now let's talk about moving a point to the right. So again, we're going to have our original point, whatever that is, which is x comma y. And then if I'm moving to the right, that means I'm adding something, but am I adding it to the x or the y? If you said x, you're right. So I'm going to do x plus some number, and the y is going to stay the same. And that's only if I'm moving it to the right. Whereas if I'm moving it to the left, I'm going to take that original point, and I'm going to do x minus a number, comma y. Okay, so if I'm moving to the right, it's going to be x plus a number. And if I'm moving to the left, it's going to be x minus a number. Okay, let's practice using this notation. Hit pause on the video and copy down example 1. Okay, welcome back. So in example 1, we have the point 3 comma 5 and it's already there. Okay, let's call this point M. Okay, now according to the instructions, which are right here, they're telling us, hey, they want us to translate the point to the right and down. And I got this information based off this rule. Okay, this is the rule they want us to follow. So rule. So if I see that I have plus 3 here, that means that I'm going to the right 3 because I've got x plus 3. if I've got -2 with the y like I do right there, that just means that I'm moving down 2. So I'm going to take that original point of 3, 5, move it to the right 3, and down 2 because the rule is telling me to do both. So if I'm moving it to the right 3, I'm going to go over 1, 2, 3. That means I'm adding 3 to this number. My new x coordinate is going to be 6. Okay. Now, whoops, I'm going to erase that for right now because I also have to move it down. I also have to move it down. So I know right now that my new x coordinate is going to be 6, and then I have to move it down 2. So 2 down from 5 is going to put me right here. So here is my new point. That's going to be at 6, and then 5 down from 2. So 5 minus 2 is 3. So my new point, or my new location, is at 6, 3. And I'm going to go ahead and call that M prime. So we read this as M prime. Okay, and that's what that little apostrophe at the M tells us. Okay. When I have something called M prime and M, we can refer to them as the pre-image and the post-image, or even just the image. So the pre-image, think of that as your before, aka the original point that we were working with, aka point M, which was 3, 5. And the image is the after, aka in this example, M prime. Okay, let's go ahead and try another example. Hit pause, copy down the example, and try it on your own. All right, welcome back. So we're going to go ahead and translate the point, -1, -2, and we're going to translate it according to the rule. So according to this rule, I've got x minus 4. So that means that I'm moving to the left 4 because I'm subtracting. I've got y plus 5. So that means I'm going up 5. So I'm going to take this point and I'm moving to the left 4. So -1 plus 4, and this is just another way of doing it. Oh, I'm sorry, not plus 4. That's going to be -4 because I'm moving it to the left. So -1 minus 4 is -5. So my new x coordinate is going to be at -5. Okay? That's your new x. Whereas my new y value, so I've got -2, that's my original, and I'm going up 5, so that means I'm going to add 5. So -2 plus 5 is going to give us 3, and this is our new y. So my new point is at -5, 3. Okay? AKA E prime is at -5, 3. And that's your new point.